Click for IB Biology. In this discussion, we're going to be looking at muscle myoglobin and its affinity for oxygen and role in the muscles as a store of oxygen. Should you wish to, there's a blank PDF of this presentation in the description, and there's also a quick quiz that you can take at the end to check your understanding of the content which has been covered. Myoglobin is found in muscle, and this pigment stores oxygen. Now, myoglobin is responsible for the red color that we see in skeletal muscle. If we look at the oxygen dissociation curve for myoglobin, we find that its curve lies to the left of normal hemoglobin, and therefore it has a higher affinity for oxygen. Now, in effect, what this means is that the myoglobin will not release its oxygen until the partial pressures of oxygen are very, very low. Translated in other terms, what this means is that in the muscle where we have the myoglobin, the muscle will use oxygen from hemoglobin for respiration. But should the muscle begin to perform intense exercise and contractions, where the oxygen is greatly used up, at that point, the myoglobin, acting as an oxygen store, will release its oxygens in the very low partial pressures of oxygen, perhaps around 2 or 3 kilopascals, and release additional oxygen into the muscle. So myoglobin is a single heme group. It has a higher affinity for oxygen than normal hemoglobin. At high partial pressures, it holds on to the oxygen, and at very, very low partial pressures, it will release that oxygen as additional oxygen to support respiration. And once the myoglobin has lost its oxygen, post-exercise, that oxygen will be replaced by blood circulating to the muscles, and this makes it part of the post-exercise oxygen consumption that takes place in post-exercise ventilation. Links to further videos can be found in the links appearing on the screen now, and also links to the channel.